Hello, my name is Julia and this is Space Daily News channel. SpinLaunch company has already conducted 10 successful flight tests of its suborbital rocket from Spaceport America in New Mexico. The most recent test was the first launch of payload from NASA, Airbus U.S. and Outpost and Cornell University. The flight test demonstrated that standard satellite components are compatible with SpinLaunch launch conditions. The test collected critical flight data as all payloads were successfully returned to Earth. The 10th flight test will be a watershed moment for SpinLaunch, as we open up the suborbital system to our customers, partners and research teams, SpinLaunch founder and CEO said. The company's mission is to provide low-cost, high-quality and sustainable access to space. Before launch, the payloads were tested at 10,000 G in SpinLaunch laboratory. The devices were then integrated into a flight test vehicle about 3 meters long. The flight vehicle was then accelerated in a test accelerator 33 meters in diameter, which is 1/3 of a full-size launch system. During the test flight, the rocket reached an altitude of 9,100 meters. NASA provided a data acquisition unit to record critical launch characteristics of the SpinLaunch kinetic launch system. The sensor set was equipped with 2 accelerometers, as well as a gyroscope, magnetometer, and pressure, temperature, and humidity sensors. After completion of the flight test, the data acquisition unit was successfully removed from the test vehicle. SpinLaunch and NASA engineers obtained important data of the launch system. For the flight test, Airbus U.S. provided its solar sensor, which is typically used for control the orientation and positioning of spacecraft. Post-testing of the device showed that the performance and operation of the sensor was not affected by stresses during the pre-flight, flight, and recovery phases. SpinLaunch is developing a space launch system that doesn't rely on traditional rockets to significantly reduce the cost of access to space while increasing launch frequency. The technology uses a vacuum centrifuge to spin a rocket and then launch it into space at up to 4,660 miles per hour. At an altitude of about 200,000 feet, the rocket must then fire its engines to reach an orbital velocity, with a payload of up to 200 kilograms. The peak acceleration will be approximately 10,000 G. If successful, such a system would reduce launch costs to $2,500 per kilogram payload. Space Daily News, like, share and subscribe.